Qualitative analysis question from February-March 2018, variant 33. Where reagents are selected for the use in a test, the name or the correct formula of the elements or compound must be given. At each stage of any test, you are to record details of the following: color changes seen, the formation of any precipitates and its solubility in an excess of reagent added, the formation of any gas and its identification by a suitable test. You should clearly indicate at what stage in a test a change occurs. If any solution is warmed, a boiling tube must be used. Rinse and reuse the test tubes and boiling tubes where possible. No additional tests for ions present should be attempted. So this is the introduction in the every question they give. Let's move on to the next part, where they have asked you, Fa3 is more concentrated solution of a strong acid, monoprotic acid Hz, which was used in the question 1 of this paper. Select two sets of reagents and suitable apparatus to use in two separate tests, test 1 and test 2, to investigate the identity of anion present in Fa3, which is acidic solution. The anion is one of those listed in qualitative analysis notes as well. So here they have given you the space for two tests that should be performed in order to identify the anion present in this acid Hz. The next point they said, complete the test boxes in the table before starting any practical work by circling whether you should use a test tube or a boiling tube and state which reagents you would use. Carry out the test and record the observations. You must carry out both test 1 and test 2. Before we select any reagent, let us see which substance they have given us. They have said here a strong monoprotic acid Hz. Now, let us recall what is a strong acid. The acid is strong when it completely dissociates to give H plus ion. In our syllabus, we have studied 4 strong acids. Number 1, hydrochloric acid HCl, nitric acid HNO3, sulfuric acid H2SO4, and phosphoric acid H3PO4 in a high concentration. It is again a strong acid. Now sulfuric acid is 2H plus containing acid. This is why we call it diprotic acid. Phosphoric acid is 3H plus containing, so it could be termed as triprotic acid. These two acids are monoprotic acid because they contain one H plus ion. This is why we call them monoprotic acid. And here in the question they have said the Hz is a strong monoprotic acid. It means now our Z could be the anion, that could be Cl minus, or it could be nitrate NO3 minus. Now in the question they have said that the anion is one of those listed in qualitative analysis notes. So if we look at the qualitative analysis notes, the chloride is also here and nitrate is also here. So we select these two reagents which can confirm the presence of chloride. So for that, silver nitrate must be used, followed by aqueous ammonia, and for nitrate, sodium hydroxide with aluminum foil must be selected. So the two reagents we will record here, and to decide whether a test tube or boiling tube must be used, we need to look whether we are heating any of them or not. So for nitrate, we see the ammonia gas liberates on heating. It means we have to heat. Therefore, in one of the tests we will select the boiling tube in which we can heat, and in the other test we will select the normal tube because the other test for chloride does not need any heating. So let's write this detail first before we proceed on to the test. So we have recorded our reagents here and we have selected which test tubes to be used. Now let's perform these tests one by one. 1 centimeter depth of Fa3 solution in a test tube, and we will add few drops of silver nitrate first and we'll see the precipitates forming or not. So if we put few drops of silver nitrate, we can see no precipitates are forming. So chloride is absent. We will take in a boiling tube 1 centimeter depth of Fa3 solution. In order to test for the presence of nitrate, we add sodium hydroxide and then we add aluminum foil. Now we will add this is aluminum foil. We will add this tube in this tube, and now we will warm this tube in order to check the liberation of ammonia gas. So ammonia gas can be tested by this red litmus paper, which must be moist. So we will moist this litmus paper. Now we will put this on this test tube so that the gas which is evolved must turn this litmus paper blue. Now we have put this litmus paper on the top of this tube like this, and now we will warm this tube. Put on this burner. So now the burner is on. Let's warm this tube and see the color of litmus paper from the exposed part. The gas has started to come out. Damp red litmus paper has turned blue. We can see from the top the color of this litmus paper has turned blue. So we have recorded these observations here, and now if sodium hydroxide and aluminum foil addition has given us the observation of gas evolved which has turned moist red litmus paper blue, that means ammonia. It shows that this anion must be nitrate, NO3 minus, because it gives you this observation. So out of these 4 acids they have given us, HNO3 is confirmed. So we will write here Z minus ion is nitrate ion. So we have recorded this here that Z minus is nitrate ion. Let's move on to the next part of this question, where they have said Fa4 and Fa5 both contain 1 cation and 1 anion. The ion present in Fa4 are different from the ion present in Fa5. All 4 ions are listed in the qualitative analysis notes. You are to identify the 4 different ions. Now let's perform these tests, where in the first test they have said to a small spatula measure of Fa4 in a boiling tube, add a 4 cm depth of Fa3 and shake the test tube. Leave the tube to stand for at least 5 minutes. Label the solution formed Fa6. So let's do this now. Now let's take a small spatula measure of Fa4 in a boiling tube. So this has a small spatula measure, and I will take this in this boiling tube, and we have to add Fa3 4 centimeter cube. This is our Fa3, which we have identified in the previous test. That is nitric acid, 4 centimeter. Okay, so fizzing is observed. So we need to test this gas also. Obviously we know that this is fizzing, means carbon dioxide, but we need to test. Now this is my solution prepared, and as they have said, leave it for 5 minutes. So let me put this in a side for 5 minutes, and now I will test the carbon dioxide which was liberated. So I will take a small spatula of Fa4 in this test tube, and I will add nitric acid here. But before I add nitric acid, let me prepare lime water also, so that I can test this whether the liberated gas is carbon dioxide or not. So here is our lime water. Let me take this lime water in a test tube, and in this test tube, when lime water is exposed to the carbon dioxide, the lime water must turn milky white. So this is my delivery tube. I will pass this through here. It is not enough. Let me take a bit more. So I have taken lime water here. Now as soon as I will add nitric acid in this test tube, I will put this over here with the rubber bung, so that the gas which is given off must be transferred to this tube, and the content here, which is lime water, must turn milky white. So if I want to add, I will take this as a support. I will put this here, and now I will take this. I will take nitric acid here, and this delivery tube will take that to this lime water solution. Now let me put Fa3 here. So the gas given off is transferred here, and you can see the lime water is changing its color to milky white. It means the gas liberated is carbon dioxide. After 5 minutes, let us see the solution in this test tube, and it is a very clear solution. So the observation for this, leave it for 5 minutes, is clear solution. So I have recorded this observation, fizzing that turned lime water milky, and a colorless solution was formed. From here we can conclude that Fa3, which was nitric acid, which we have identified in the previous part, and when it has been added with this Fa4, so fizzing means carbonate was present, because acid gives carbon dioxide when it is added to any carbonate salt. Therefore, in Fa4, one of the ion present is carbonate ion. Now, let us proceed with the next part. In the next part, they said, to a 1 centimeter depth of Fa5 in a test tube, add aqueous sodium carbonate. So let's perform this test now. Now let's take 1 centimeter depth of Fa5 in a test tube and add sodium carbonate. So here is my sodium carbonate. Using dropping pipette, let me add here sodium carbonate and see if there's any change happening. So when I add sodium carbonate, white precipitates are forming. So we will record this observation now. So I have recorded this observation. Now let's proceed on to the next test, which says to a 1 centimeter depth of Fa5 in a test tube, add aqueous sodium hydroxide. So let's perform this test now. Let's take 1 centimeter depth of Fa5 in a test tube and add aqueous sodium hydroxide. Now, using dropping pipette, let me add sodium hydroxide and see if there is any change happening. So this is the tube, and once I add few drops, white precipitates are forming. And if I add excess of sodium hydroxide, precipitates remain insoluble. So let's record this observation now. So I have recorded this observation here. Let's proceed on to the next test, which says to a 1 centimeter depth of Fa5 in a test tube, add aqueous ammonia. Again, dropwise and excess. So let's perform this test now. Now take 1 centimeter depth of Fa5 in a test tube and add aqueous ammonia, dropwise first, followed by excess. So here, if I add few drops, white precipitates are forming. And when we add aqueous ammonia in excess, those white precipitates remain insoluble. So let's record this observation now. So I have recorded this observation. From here, if we want to conclude that Fa5 with sodium hydroxide and aqueous ammonia has given us white precipitates which were insoluble in excess, and if we look at the cation table, the only cation that gives white precipitate insoluble in excess in both the reagent is Mg2+. It means from here we can conclude that Fa5 has a cation Mg2+. So let's record this also, that Fa5 has Mg2+ cation. So I have recorded that Fa5 has Mg2+. Now let's proceed with the next test, which says to a 1 centimeter depth of Fa5 in a test tube, add few drops of silver nitrate. Silver nitrate addition means they are looking for halide ion. So now let's perform this test. Take 1 centimeter depth of Fa5 in a test tube and add a few drops of silver nitrate. So here, if we see closely, so no change is happening here. It means halide ion is not present. So I have recorded here no change. The next test is to 1 centimeter depth of Fa5 in a test tube, add a few drops of aqueous barium chloride or barium nitrate, then There is a dotted line in between. It means in the same test tube we need to add 1 centimeter depth of suitable acid. Now in order to find which acid to be added, look for the test of anion, which says for sulfate and sulfide in these two tests we add barium 2 plus and white precipitates are formed with this barium chloride or barium nitrate both. And once we add excess acid, the precipitates become soluble or insoluble. If the precipitates are soluble, it means sulfite is confirmed, and if the precipitates are insoluble, sulfate is confirmed. It means if we are looking for sulfate or sulfite, we cannot add sulfuric acid. So here, if we want to select the acid, which acid can be used? Hydrochloric acid or nitric acid. So firstly, we will add aqueous barium chloride, then hydrochloric acid, and we will observe the change. So let's perform this test now. Let's take 1 centimeter depth of Fa5 in a test tube and add barium chloride first. So if we add barium chloride, look for the precipitates. White precipitates are forming. And if we further add dilute acid, and that is of course hydrochloric acid, look for the solubility of these precipitates. Precipitates are not dissolving. Let's take a bit more of hydrochloric acid. So the precipitates are not dissolving. It suggests that this Fa5 has sulfate anion present. So let's record this observation also. So here I have recorded that white precipitates are formed and the precipitates are insoluble, which suggests that it has sulfate. So I have recorded here that Fa5 has magnesium 2 plus and sulfate 2 minus as one of the cation and one of the anion. Now let's proceed with the next test, which says to 1 centimeter depth of Fa6 in a test tube add aqueous sodium hydroxide. Now where is our Fa6? Fa6 is actually here. They have asked you to add Fa4 in Fa3 and leave the solution for 5 minutes and label the solution Fa6. So the solution which we have left here was Fa6. So I have labeled the solution as Fa6. Now we will add sodium hydroxide in this Fa6 stepwise, like for the formation of precipitates, few drops and then excess. So let's perform this test now. Let's take 1 centimeter depth of this Fa6 solution in a test tube and add a few drops of sodium hydroxide and once we add sodium hydroxide, no change is coming up. So we will record this observation now. So I have recorded this observation, no change. The next test is to a 1 centimeter depth of Fa6 in a test tube, add aqueous ammonia. Now let's perform this test. Let's take 1 centimeter depth of Fa6 in a test tube add aqueous ammonia, again dropwise followed by excess. So let's observe. No change, no precipitates are forming. If we add excess, no precipitates are forming. So we will say no change. So we have recorded these two observations. Now let's look in the table of cation, which cations give this type of observations. Now if we look at this barium 2 plus, it doesn't give very good precipitates, and also with calcium it doesn't give you very good precipitates in none of these two solutions, sodium hydroxide and aqueous ammonia. So it could be barium 2 plus or calcium 2 plus. We are not still sure, but the idea is it could be barium 2 plus or calcium 2 plus. Anyways, let's proceed on to the next test, which says to 1 centimeter depth of Fa6 in a test tube add sulfuric acid. Okay, so this is the test to differentiate in between these two. Why? Because if we are adding sulfuric acid, so barium will give you barium sulfate and calcium will give you calcium sulfate. And calcium sulfate is soluble and barium sulfate is insoluble. So in this test, we can judge whether it's barium or calcium. By forming precipitate, it shows barium. And if the precipitates are not formed, it means calcium. Because we know that as we go down in group 2, the solubility of sulfates decreases. So barium sulfate is insoluble. Let's perform this test. Let's take 1 centimeter depth of Fa6 in a test tube. And add sulfuric acid. And we need to see closely whether white precipitates are forming or not, because this is the differentiating test. So if we see the precipitates are not yet there, it means precipitates are not formed, means it's calcium 2 plus confirmed. So let's record this observation now. So here I have recorded the observations, and I have concluded also here that in the above two tests, barium 2 plus or calcium 2 plus were the probability, but from this test adding sulfuric acid, we got to know calcium 2 plus is confirmed. Because the precipitates were not formed, it means barium sulfate wasn't the product. And now if we conclude, this Fa4 also has got two ions confirmed, calcium 2 plus and carbonate 2 minus. Now we know both the cations and anions in Fa4 and Fa5. Now let's proceed on to the last part of this question, which says to a 1 centimeter depth of Fa6 in a test tube, add 1 centimeter depth of Fa5. Now we know that Fa5 here is magnesium sulfate, and we are adding a solution formed in this part, that is Fa6, with this magnesium sulfate. So let's perform this test now. Let's take 1 centimeter depth of Fa6 solution in a test tube. And add Fa5 solution and observe what is happening. So white precipitates are formed. So we will record this observation now. So I have recorded the observations here. White precipitates formed. Now let's move on to the next part of this paper, where it says give the formula of acid you added to the mixture of Fa5 and aqueous barium chloride or aqueous barium nitrate in part C. So if we look here in part C, this was the test where we have selected an acid and when we add barium chloride or barium nitrate, we try to look for sulfate or sulfite. In this case, if we are looking for sulfate and sulfite, we have said in place of this strong acid, only HCl or HNO3 can be used, because sulfuric acid, if added, can counteract with sulfate ions. Therefore, we can select here hydrochloric acid or nitric acid. This is why when they have asked here which acid should be added, we will write HCl or HNO3. So I have recorded here the acid. Now let's move on to the next part, which says identify the ions present in Fa4 and 5 from your observations in C. Now in Fa4 and 5, we have found in Fa4 calcium and carbonate, and Fa5 magnesium and sulfate. So we will write them. So I have recorded here the ions found. Here we comes to an end of 16-mark qualitative analysis question from February-March 2018 33 variant.